Hey there, I'm Travis Black with Alchemy Education, and I'm here to help you with the chemistry. Looking at the problem that's been provided to us here, it's giving us an amount of sodium bromide, and it's asking for a different amount of sodium chloride. That means then that this is going to be a stoichiometry problem. In chemistry, stoichiometry is just a fancy word meaning cooking with chemistry. And in order to make sure that we're doing our cooking correctly, stoichiometry correctly, then we have to have a balanced chemical equation. So let's start with that. Looking at what's been provided, this is not a balanced chemical equation. And when I say balanced equation, that means the same amount of each element on both sides of the arrow. And in order to do so, we just hop back and forth to make sure that it's even. There are 2 chlorines on the left-hand side, which means we're going to need 2 chlorines on the right. Likewise, since there are 2 bromines on the right-hand side, we're going to need 2 bromines on the left. Now that we have a balanced chemical equation, we can use our recipe, and we can go ahead and find our theoretical yield. Theoretical yield is how much we can make, or how much we think we can make, and that's always done through the math. That's the only way to do it. And so theoretical yield is always according to the math, how much can we find? And so like all Stoich problems, same 3 steps. Number 1, start with your provided and convert it into moles. And the reason we have to do that is because a balanced chemical equation uses the unit mole. Just like when I have a recipe for French toast, I have slices for bread and I have cups for milk, or I have teaspoons for cinnamon. Well, in order to use our recipe, in order to use our equation, we have to make sure our unit is in moles because it's the only way it's going to work. So step 1, convert into moles. Looking at what we have 67.8 grams of sodium bromide. And in order to convert this into moles, we use the molar mass. According to the periodic table, we would add 1 sodium and 1 bromine together, and they would have a molar mass of 102.89 grams of sodium bromide for every 1 mole of sodium bromide. And we set it up this way in order to cross off the words. The whole point of this process is to cross off the units and the words. The math comes along later. Our calculator can take care of that. Step 2, now that we have it in moles, we can use our balanced chemical equation to convert from sodium bromide, the unit we have, to sodium chloride, the unit we want. And so according to our equation, there are 2 moles of sodium bromide for every 2 moles of sodium chloride. Again, we cross off what we can, and in this case, that's the word moles and sodium bromide. Now that we've converted it into the chemical we want, sodium chloride, now we need to convert it into the unit that we want. And in order to do that, we again would use our molar mass. Since we have moles of sodium chloride, and it's asking for grams of sodium chloride, we use the molar mass from the periodic table, adding 1 sodium atom and 1 chlorine atom to get a molar mass of 58.44. 58.44 grams of sodium chloride. Looking at our setup, all of our units cancel that they should. We're ending with the unit that we want. And if we plug it into the calculator, that tells us our theoretical yield is going to be 38.5 grams of sodium chloride. That's the first question answered, is we have that. The second part then involves percent yield. Percent yield is a measure of how good you are at performing your experiment. And it is always the actual value, what we get from the experiment, divided by theoretical, what we get from the math, and then times 100% to get our percent yield. In this case, we actually know our percent yield as 82.30. And we know our theoretical of 38.5. From there, we set it up like an algebra expression and we solve for our unknown. We have absolutely no idea how much the actual is. We know the theoretical is 38.5 grams. And if we multiply that times 100, that gets us our percent of 82.30%. From there, we solve for our unknown by isolating the variable. So we reverse our algebra. Since we are multiplying by 100, we're going to divide both sides by 100. That cancels it from that side and moves it over here. In addition, that allows us to get rid of the unit percent. Lastly, then, this A, our unknown actual yield, is on top. In which case, in order to isolate that variable, we would need to multiply both sides by 38.5. Multiply both sides by 38.5. That cancels it on the left, and that leaves us with only our actual yield. So if we plug it into the calculator, 82.3 times 38.5 and divided by 100, that gives us an actual yield of 31.8 grams of sodium chloride. I hope this explanation helped you, and I look forward to your next questions.